So, let us say I have two bipolars. So, this is your PTAT generation. This is IC1 and let us call it VB1 Q1. So, what is VB1? Expression for VB1? VTLN IS1 and VB2 what will be that? ln of IC1 by IS1 multiplied by IS2 over IC2. And I can call it delta VB because I am looking at the difference of the two. So, I can have two situations here. In what condition the IS1 and IS2 will be same? Same area. Okay. So, if you have same area, then they will be same and they will cancel out, and if I have a same current, then your delta VB will be 0. So, which means you need to either, in order to generate this difference, you need to have a different current. If you have a same size, then you have a different you need to have a IC1 and IC2 to be different, or if your IC1 IC2 are same, then you need to have a different size, so that your IS1 IS2 can be different. So, in this you can have, you always need some constant here to make sure your this ln terms should not become 0, otherwise your delta VB will become 0. So, case 1, IC1 is not equal to IC2 and IS1 equal to IS2, which means Q1 equal to Q2 in terms of size. So, your delta VB will become VT ln IC1 over IC2. Now, let us say IC1 equal to m times of IC2, then delta VB will be VT ln m. Okay. Now, m is constant, Vt is proportional to temperature. So, now you choose the m to change the slope. So, ln m is a constant term which will define the slope for your Vt. Case 2, So, if I use Q2 equal to m times Q1, then this implies delta VB equal to VT ln m, because IC1 IC2 will cancel out and your reverse saturation current is proportional to your area, larger the area. So, that will become m times of your IS1, IS2 will become, and you will get the same expression. So, most of the time we use this case 2 actually, we always make the IC1 equal to IC2 because this gives us more accurate result compared to the other one. So, we rely only on the difference between the reverse saturation current by introducing the area difference between the transistors. So, now you can change the area or you can change the currents in the two bipolars and you can change the slope and get the band gap. Okay. But since it is coming as a Ln term, which means m required might be quite large. Okay. I mean you can take just do the calculation in order to get a 2 millivolt slope 86 microamp. So, 2 millivolt divided by 86 micro, that is what your the multiplication factor you require. So, how much is that? Just use your calculator and so in order to get 23 from Lm, what should be the m? That is quite large, huh? So, which means your area will be bloated. So, usually this you try to keep this m factor small and introduce another proportionality factor. So, let us say m you can maybe choose 10 or so. So, the size of one transistor will be 10 times of the other and then have another proportionality factor by modifying your circuit in such a way. So, that can be done through resistor divider. So, let us say with this VTL and M I have another factor which is R1 by R2. Now, you change the R1 by R2 ratio and get the required slope. Okay, so, we were talking about band gap reference and we will continue with the same. So, as we saw what we need actually, we need one voltage which is proportional to temperature, other one is inversely proportional to temperature, and if we have the same slope, then they will cancel out, same and basically negative opposite sign, they will cancel out and you will get the output which is constant across temperature. Okay. So, what we need actually, you know how, so we need PTAT and CTAT and you add up the two and what you get is VBG, okay, provided that your condition delta of V of PTAT over delta of T should be minus delta of V of CTAT over delta T. Okay. So, if meet this condition, you will get a voltage constant across temperature. So, how do we implement CTAT? So, how do you implement CTAT voltage? We talked about that yesterday. Diode or VB. So, if you connect your bipolar in a diode connected manner, it will give you VBE and VBE is inversely proportional to temperature. correct. This is equivalent to this, so you can have a R also, or you can replace it with diode, or you can replace it with PNP and make this as ground. So, this R could be current source also. So, in all the cases you will get VB, and most of the time we use PNP because in the standard CMOS process what you get actually the parasitic bipolar, you do not get active bipolars. So, there is a difference between parasitic and active. Active bipolar is basically is fabricated through the process and it is a mostly vertical actually, and the parasitic bipolar, when I say, you get by default when you fabricate the CMOS, PMOS and NMOS. So, by default you get the P diffusion, N diffusion and P diffusion. So, 3 diffusions you get, and all 3 make your collector, emitter and base, and you get a basically PNP device, and since this collector is built on substrate, P type substrate, that is why, and substrate is mostly grounded. So, you get a bipolar by default whose collector is grounded or connected to substrate, and that is why you do not have a freedom to connect to collector anywhere else, but you have to ground it. So, then if you tie your base to the, and base is N type here, and tie the base to the ground, then what you get again the same diode behavior. Okay, so, the difference between active and parasitic is the gain, the beta actually of these bipolars is very bad compared to the active. Active may have like more than 100 beta or so, these guys may have a, I mean much less than 10 or so. Okay, so that is why we mostly use these substrate PNPs in order to design the band gap for standard CMOS. But if you have a process which has a active bipolar, then you are free to use. Okay. So, irrespective of what you use, I mean in my circuits I will draw the diode instead of drawing PNP or NPNs. So, by default you understand that you have to replace that with a diode connected NPN or diode connected PNP. Okay, so implementing PTAT. So, PTAT voltage is what? Delta VB VT ln m, and this is your PTAT. So, how do you do that? You can have 2 devices. So, if this is 1x and this is let us say m times, and these currents are same, I will call it IB, then the difference between these two will give you delta VB or PTAT. So, which means what you need here, you need 2 devices, take the difference. So, this first device 1x will give you VB 1, VB 2. So, VB 1 you can use as a CTAT also, and the difference can be used as PTAT, but slopes are not different. So, you need to scale that. So, which means, so VB is fixed, VB is not scaled, but delta VB needs to be scaled to match the slope of your VB. So, now you have a VB. So, now have the same adder and you have a delta VB, and this guy needs to be scaled by, let us say, K. Now, what you get, VBG equal to VB plus K times delta VB. So, VB is straightforward. Now, you have to see how to generate delta VB. So, one possibility could be instead of taking the difference of two voltages, I can first generate the current and dump into the resistor. So, let us see. So, let us say this guy is IB equal to delta VB by R2, and I will come to that how to generate this. I have one resistor which is called R1 and I have a diode. So, this is VB. So, what is this voltage? Plus R1 over R2 into delta VB, correct? So, which means this is nothing but your band gap and K equal to R1 by R2.